I'm Jelay and I'm going to solve 5 problems from the book Advanced Engineering Mathematics by Wiley, 5th edition. And my teacher has given me 5 problems to solve. So, the first problem is in page 32, number 7. Prove that the substitution x equals vy will also transform in homogeneous first-order differential equation into
First
one
thing you'll
which
do is to have a homogeneous first-order differential equation. So I have this equation, x squared plus 3y squared dy minus 2xy dx equals 0. So substituting x equals vy and its derivative dx equals v dy plus y dv. So the equation will transform into v squared y squared plus 3y squared dy minus 2 times vy squared v dy plus y dv equals 0. So we can rewrite it into v squared y squared dy plus 3y squared dy minus 2v squared y squared dy plus 2v y cubed dv equals 0. We can reduce this equation by multiplying 1 over y squared. So the equation will be reduced into v squared dy plus 3dy minus 2v squared dy plus 2vy dv equals 0. So combining like terms, this will transform into 3 minus v squared dy plus 2vy dv equals 0. So by separating variables, this equation will be transformed again into dy over y minus 2v over 3 minus v squared dv equals 0. So this may prove that homogeneous first-order differential equation can be transformed into a separable equation by substituting x equals vy.
Second problem was in page 35, number 10. xy prime plus 2 times 1 minus x squared. We can rewrite this equation into this equation. xy prime plus 2y times 1 minus x squared equals 1. This is a linear first-order equation that must be transformed into this form. dy over dx plus p of x times y equals q of x. So we must reduce this equation by multiplying 1 over x. So this will result into y prime plus 2y times 1 minus x squared over x equals 1 over x. So we can rewrite this by y prime plus 2y times 1 over x minus x equals 1 over x. The second step is we must find integrating factor. So remember that this x term is p of x. So multiplying it by 2, this will result into 2 over x minus 2x. So the integral of p of x dx is equal to the integral of 2 over x minus 2x dx. If we integrate this will result into ln x squared minus x squared, or equal to x squared over to the x squared. The next step is we must multiply the right-hand side of the given equation by the integrating factor. Then, in the left-hand side, we must multiply it by y, resulting to this equation, y times x squared over to the x squared equals 1 over x times x squared over to the x squared, resulting to this equation. then we must integrate this right hand side. So, integrating this, we will have this resulting into negative e to the negative x squared plus c. Then we have this equation, y equals e to the x squared over x squared times negative e to the negative x squared plus c. Then by distribution, this equation will result into this final equation, y equals 1 over x squared plus e to the x squared over x squared times c.
The third problem is in page 38, number 13. Y times y prime plus y squared is equal to x, which has initial value of y equals to sign. If we pi over 4 multiply the equation by 1 over y, we obtain y prime plus y equals x over y, which is a Bernoulli equation with n equals negative 1. From the substitution, z is equal to y to the 1 over n, we will get z is equal to y squared. So, differentiating it, we have dz is equal to 2y dy, or dz over dx is equal to 2y dy over dx. And then, multiplying this to the equation, Bernoulli equation, we will get dz over dx plus 2y squared equals 2x. We all know that y squared is equal to z. Z is equal to y squared. So, substituting it, we will get dz over dx plus 2z is equal to 2x. This is a simple linear differential equation whose integrating factor is e to the integral of 2 dx is equal to e to the 2x. Multiplying the linear equation by this factor, we will get z prime equals 2x e to the 2x dx. Since our linear equation is this one, we will multiply this by the integrating factor, we will get this. We need to integrate the right-hand side of this equation, which is 2 times x e to the 2x dx. So we will let e to the x u equals to e to the x du equals to e to the x dx. So to find x, ln u is equal to x ln e. So x equals ln u. So by substitution, we will get this. 2 times the integral of u ln u du. So we will have this value. 2 times 1/2 u squared ln u minus 1/4 u squared. So we will get this reduced form u squared ln u minus 1/2 u squared. So we know that u is equal to e to the x. So e to the 2x ln u, e to the x, minus 1/2 e to the 2x. So we can rewrite this form into this. Since ln e is 1, so we will get this equation, x times e to the 2x minus 1/2 times e to the 2x plus c. Multiply this equation by 1 over e to the 2x. So we will get x minus 1/2 plus e to the negative 2xc. So we now get z is equal to x minus 1/2 plus e to the 2xc. We know that the value of z is y squared. In this substitution, z is equal to y squared. So we substitute z to be y squared is equal to x minus 1/2 plus e to the negative 2xc. The value of y is equal to sine pi over 4, which is square root of 2 over 2, and our value of x is 0. We will get 1/2 is equal to 0 minus 1/2 plus c over e to the x, or we can write this into 1. So we'll get 1/2 plus 1/2 equals c, or c is equal to 1. So the final answer, substituting this c equals to 1, the final answer will be this. Y squared is equal to x minus 1 over 2 plus e to the negative 2x.